So we can always
Okay.
very nice. Thank you.
All right. Um, this introduction to knowledge-based systems. So we're looking at the course, knowledge-based systems, knowledge-based and hybrid systems. Now, I'm going to explain what knowledge-based is and then what the hybrid is coming in to do there. When we say knowledge-based, we are just looking at what you ordinarily know as expert system. Expert system are a subset of knowledge-based systems. So by knowledge-based systems, we are looking at using artificial intelligence to create knowledge, a knowledge domain or a knowledge dump site. Let me call it dump site. Like I'm trying to use what we all know. If I say a dump site, now you're thinking of excavation sites, right? Getting sand somewhere, dumping it somewhere. That's what I want to use to as analogy to kind of explain this. Now, let's say you're an expert in a particular domain. You have all it takes, you know a lot about it, and then you want to contribute this knowledge so that people coming up can actually make use of your knowledge in making inferences. That is what a knowledge-based system kind of offers. Now, an example of it, which we call a subset of knowledge base, is an expert system. An expert system actually kind of creates or provides knowledge in a specific domain. For instance, you can have expert system for diagnosis of malaria, for this, for that, and then example of expert system, we heard about mycin expert system. So that's just an example of knowledge-based system. Now, for knowledge-based systems, they use kind of different types of reasoning. It can be fuzzy reasoning, it can be inductive, deductive, abductive, analogical, and then common sense. These are the types of reasonings that can come in and be used in knowledge-based systems. Now, we say the component of knowledge-based systems to have the knowledge base itself, the inference engine, and a user interface. Now, the inference engine is what connects the user interface to the knowledge base. Okay, so it is like the middleman. It just connects the you know what I mean by you want you were on in computer science and this is a PhD class. So if I say um user interface, we all know what I'm talking about. It's like a presentation that's a layer where the user directly interacts with the system.
That's right.
User might not have direct access to the back end, might not have direct access to the storage, might not have direct access to the scripts that make decisions, but he can comfortably interact with the user interface, ask questions, and then those questions can be processed at the inference level, and the information can be retrieved from the knowledge base and then provided back to the user interface. So this is what it is all about. An example applications, we have the diagnostic, we've mentioned diagnostic like mycin, which is used in um, treatment cases. So to diagnose, it can be health diagnosis, it can be fault diagnosis. I'm sure you've heard about using computers to diagnose fault in cars. So those are diagnostics. Then configuration based, where an expert contributes his knowledge. And if you now want to configure certain, if it's based on that knowledge, you use that procedure to carry out that. Then we also have decision support systems. These are still um, within the knowledge base system. Now, this we already talked about this expert system, subset of the knowledge base, and then we say we are structured about. So we'll be going at, we'll be looking at the symbolic type, and then the one symbolic is also AI, but it's based on rules and all that. Then we can now look at the learning aspect also. When you think of symbolic, you're thinking of the rule set, and all that, getting the rules set, making judgments or making decisions based on set rules, means those rules, then automatically this is the decision that can be inferred from such a case or such a situation. Then, but when it is learning, it has to learn from data. I don't know if we're together. When we talk of learning, we think of data. There has to be available data from which the system learns. And after it has learned, it can now make predictions, it can now make certain inferences based on observation, based on what it has learned from the data available. So this is an example that we already mentioned, we might see. We say components of knowledge-based systems, the knowledge base itself. The knowledge base has to do with where you dump the facts and the rules about a particular domain. Let's say I'm looking at creating a knowledge base for malaria, or a knowledge base for, let's see, something that is not too common, something that old people have not used over and over. Who can tell me something? I want it to be interactive. Give me a challenge, a problem that we can provide facts and rules about, and then we'll generate, well, that will be in my next class, because within this week we should be having 3-4 classes so that your exams should be seamless. Okay, we will have practical the next week. So I'm just going to do introduction. Sorry?
Do you want us to say something? Do you want us to say something?
Yes.
Do you want us to say something?
Yes, please.
Okay, I think knowledge base. On knowledge base and the knowledge base, right? The domain. I'm talking about the domain where we can apply that knowledge. I think we can apply knowledge on, we can get it from system repairs. I think this is something that is closer to what we do. Let's say diagnostic system repairs. Let's say finding fault. We can meet an engineer who is grounded. We can extract his knowledge and build it into something that is useful. Are you with me? You can network, no worry me.
Hello.
Hello.
Yeah, can you hear me?
Are you with me?
Yes,
I can hear you now.
Okay, go ahead.
I talked about, at least we are bringing it closer to what we know.
Okay.
You know, we can extract the knowledge you have and build a system that can teach students about this advanced knowledge base and help this system. Because we have the knowledge, we can gather it the way you are teaching us, we can put it together, then build an inference, then have a user interface. Now, you don't need to be suffering yourself trying to teach us. You can just go there, use the system, and have the same knowledge, because it's the same knowledge you have that you have built into a knowledge base.
Okay.
You get me? I think that's gonna.
That's a good case. Now, but what you're saying is like, what kind of reasoning will that fall into? Because let's say I contribute my knowledge and then drop it in a knowledge base, right? Don't forget, we have 3 parts of a knowledge base system: the user interface. That means we have to now create an application, right? And also generate an inference engine, so that, knowledge base is not a teacher. Are you hearing me? Yeah, it is not like a teacher. What it does is draw conclusions based on facts and available facts. So where it can be perfect is in, let's say, in hospitals, where you need to know what is wrong with Mr. A. And then how do you know, okay, does he have prostate cancer? Based on the knowledge of the symptoms of prostate cancer, you ask him, Oga, do you have fever? He says yes. Do you have enlarged this? He says yes. Do you have sleepless nights? Is your BP high? I don't know. I'm just using some, like, talking like not from details, but I'm giving instances. So from his responses, you're matching his responses to the content that the knowledge base contains. That if the person has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 symptoms, and these 10 symptoms matches prostate cancer, you can now declare or infer from that other, see what we suspect. I hope you get. You can also use it in diagnosing faults, car faults, system faults, whatever virus attacks and all that. Is your system behaving in so and so? So based on behavior of certain observations, you can now match it with what is contained in the knowledge base and make inference and draw inference from that and conclusively say, see what is wrong with your system. It is so and so type of malware. It is that, because see how it behaves. It is a Trojan horse. Okay, it is not Trojan horse, it is this. Based on the behavior that you have seen in the case exhibit. So, but in learning, when you talk about donating to learn, I don't think, okay, somebody raised their hand. Yes, go ahead, please.
Okay, good afternoon, ma. Good afternoon, everyone.
Yes.
Okay, ma, sorry. I don't know if you are done responding to his answers.
Yes,
I wanted to, okay, make it, you were talking about where this can be applied, right?
Yes.
In the first one you talked about is the diagnosis, that's the healthcare section.
Both healthcare, system repairs, car fault detection.
Okay. I also want to just in answer to your question, agriculture too. I think this can be applied for majorly for pest and disease identification.
Pest and disease, green life.
Yes, even livestock's health monitoring.
If you behave this way, behave that way, you conclude,
yes,
and then you can now know
soil management and crop planting and other precision farming generally.
Precision, it has to do with precision. Like you don't want to do guesswork, but you want to now specifically say, I think it's even AI has built some apps on that now. If you just take a snapshot of a disease on plants, you can now conclusively say, see what is wrong with these plants.
Exactly. All you need to do sometimes, all you need to do is to scan the leaf or the plant itself. It takes it and then and then start diagnosing and then exactly to tell you that there's a problem with this plant and look at the possible solution to what you would do or what you can do to.
And most times, if you apply it, it works.
Exactly, it does. It does.
That's because somebody.
I've tried that one in rice farm. You know, there's an app too. Anyway, thank you, ma, for this. Thank you.
So we are. You see, even the course program is what do you call it? Is 3 years. Even though this course can now come and then end for the semester, but the projects, we're going to get into the project part where we're going to still work on this area again, please, if you permit me, because I would want us to understand this better, use it, and then be able to create knowledge base, be able to create inference engine, and then try generating interface for it. If we can successfully do that, I think I can say, okay, we've done something okay. So let me just run through this introductory part. Next class, we'll go through the practical session. Now, the life cycle of expert system. You know, in computing, we don't just get up and build software. Let's say if it's a software program that we're talking about, we have what we call life cycle of software programs, what we call software development life cycle, right? Now, in this expert system, it's also the same thing. If we're talking about software development life cycle, you talk of problem identification. You have to identify the problem you want to solve, then feasibility study, analysis of the old system which you're trying to change, and so on. Then you do the design of the system, you do implementation, testing, and maintenance. So now, the software development lifecycle and life cycle of an expert system development is the same in the last part. Well, even the first, just language disparities. Let me use that. Identification means where do you want to deploy this? Somebody has mentioned agriculture, so we can say health. If you choose where you want to mention it, and that's the project you'll be returning for me as CA in this course. So you have to identify an area you want to apply your knowledge base, and then conceptualize it, formalize, implement, test, and maintain. When you successfully do that, I can now score you 30 marks of NCE. Okay. This is just the list. I'm going to still send you these PowerPoints after the class. Now, applications, we have medical diagnosis, engineering fault analysis, financial. So you already know so many other areas you can apply this. Okay. Then the techniques for representation of knowledge. Now, hello, can you hear me?
I can hear you.
Okay, thank you. Now, when we say knowledge representation, for instance, that knowledge you want to generate or that knowledge base you're trying to create in a particular domain, how do you bring it in a form that AI can now be applied to it? Like we just talked about agriculture, where you just take a snapshot and from your snapshot, decisions can be made, okay? Now, how do you convert real life scenario that you're looking at leaf? The leaf is withered, the leaf is having issues. How do you convert it to a form that artificial intelligence can now start interacting with the leaf and to take decisions and bring solutions? That is what this representation domain area is talking about. In the representation, we will look at the techniques that each domain applies in order to transform the ordinary real life scenario into a form that is usable by AI systems. Okay, so we're going to be looking at different techniques for different domains. Now, is it declarative? Is it procedural? Now, declarative means like the one we talked about, leaves again. Okay, see this snapshot you're posting to me. I've seen it based on what I have in my database. This disease is so and so. Like you are sure, you are certain of, I am certain that it is this. I hope you understand. And in most cases, machine learning has been used to generate that. It could be that that particular leaf disease, let's say pictures of it up to like in thousands, 10,000s, 1 million pictures has been posted in a particular knowledge engine, and then used it to assert that whenever any picture like this comes and you match it to this database, conclusively states, infer that it is so and so disease. So whenever you take that snapshot and post it to that app, the app matches it to the database where pictures of different leaf diseases have already been posted, trained, and learned. Do you understand? By the system. So as you're posting, it can conclusively match it to a particular section of the diseases and say, okay, now this type, no be this type. I hope you understand. And since it is this type, see what you will do for solution to come. So that's like machine learning aspect. It has used like we can post pictures of different dog species in machine learning, so that if you now post an animal picture, it can conclusively state that this is a dog or this is a goat. I hope you understand. It has learned from multiple pictures of different species of dogs, so that anytime a picture of any format or any species of dog is posted, it will just say, this one a dog. I hope you understand. So that's when it is declarative. The facts are there. You have put in the facts in your knowledge engine, and then based on the facts, the inference engine receives your comments from the user interface, then sends it to knowledge engine for confirmation. Knowledge engine, where the facts are deposited, states what happens, returns it to the inference engine, who now transforms it back to you, stating, see your report, see your results. In procedural type, you can now talk about a sequence, a procedure, a process. You cannot just say, it is this. You have to say, step 1, do this. Step 2, do this. Step 3, you understand? Now, an example of this, like, is giving you, I said driving a car. If you have heard about autonomous vehicles have rules, right? There's Tesla, there's so many of them, but now if I ask you to create an autonomous vehicle, write a program that allows, I don't have time in this course. That's one area I have fun, working. I like working in autonomous vehicle. Now it gives you error differential, and you keep using that error to calculate the distance to an object. And as you calculate, it tells you it is now 25. It gives you the distance, and based on the distance, it gives you the error. And you use both the distance and the error to calculate how the car moves, whether it goes to the left or whether it's going off track. Yeah, things like that. So that one comes under procedural. You cannot assert 100% because there's an error that gives you the information with which to make decisions. Error value, okay? So we have, can be declarative, can be procedural. These are, now also it can be structured, it can be unstructured. Of course, when I say structured, you know what I mean. Like in machine learning, yes, when we say structured or unstructured learning types, you know what it means. That one has table, it has heading, tables have table headers like variable names, and everything is grouped according to the variable names and all that. So in this case also it can be structured or unstructured. Just the same format that you use in machine learning. Structured is the same here, as in can be tabular. Databases, of course, are structured in nature. Ontologies, like your web and details, come under the structured parts. Now, videos and texts and audios come under unstructured formats. Okay. Semantic networks also, well, you know what we are looking at? So you can tell me this, what I'm talking about here. Representation of the knowledge, right? In a form that AI can begin to work with it. I hope you understand. So any knowledge you're representing, you should talk about, are you representing it in a structured form? Are you representing in unstructured? Is it from nodes? Like the nodes are the concepts that you have about it, and then the edges are the relationship that exists between the concepts. So this is just an introductory part. By the time we start, when we get to the representation part, we'll see how to represent using semantic networks. We'll see how to represent structured data on structured concepts. We'll see also how to represent unstructured and all that. Then ontologies, like I said, it has to do with the web and then natural language processing. There are tools used for it. We'll have the the ProSage tool, but I don't know, maybe I'll just use the ProSage. That's one I've used before. The OWL, I've not used that. So we use the ProSage tool. Now, when we say rule-based, of course, we've all written programs. We are in computer science PhD class. We've all written programs before. That when you're writing any program, no matter the language you're using, and you say, if so and so, then it simply means that if this condition is true, then let so and so conditions and so and so statements be applied. I don't know if you follow what I mean. Let's say I'm writing a program in let me say Java. Java does not use then, but it is implied. Do you understand? Okay, BASIC uses then. If score greater than or equal to 70, then grade equal to A. That is an example of a rule structure. That means if so and so condition, if fever, headache, high BP, yeah, you can now list if so and so. You can use even a nested if for that. If this case, and then a next if. That means if condition 1 is true, condition 2 is true. That means you're nesting second condition based on first condition. You understand? So you can now use that to nest and say if this case, this case, this case, then conclusively states that you have malaria. That's a rule-based representation. So we also have that if fever then suspect flu, that's an if, then the forward and backward chaining system also. I hope that even my next class, if I can bring all these together in 1 or 2 classes, I would really like that. Okay. We have frames and scripts. When I say frames, you're thinking video. Now this part has to come with unstructured formats. You know, we are thinking of representing. I want to keep repeating this so we don't get lost. Representation of what? Our context, so that AI can work on them. Okay. When we say frame, a frame is simply an image, and multiple images put together make what you call a video, right? Now, frame by frame, let's say I recorded a video of someone dancing, a child that is dancing. If I want to now break them down, I'll just do, there are tools for doing this anyway. Use that tool to break down this into frames. Let's say that video of 1 minute can now be having like 50 frames or 100 frames. Is a video, quite all right. But that video is made up of different frames, different positions at different instances. Maybe, and then a smooth video is said to have 24 frames in 1 second. Okay, like we use this when we are teaching graphics and animation. So we'll say 24 frames in a second. You know what a second means? Like, you know how the clock hand moves, that's 1 second. But when you have frame 1, frame 2, frame 3, up to 24 static images per second, it gives you the effects of real life movements. So all the videos you're watching are just made up of multiple frames, multiple pictures. So let's say I have 100 pictures taken differently, and I bring them together. I use an application or a good software for video editing, put them together, and then run them as all of them. Just take the time of running all those pictures to be 2 seconds. Then you just have a perfect video for yourself. So I don't know if I'm making sense. Are we together? Then when I talk about when you hear script, of course you're talking about the web. Okay. Then hybrid representation. When we say hybrid representation, we are talking about these techniques now that we've listed. Either you're looking at rule-based or ontology, which is the web-based or the system-based, or you're talking about those logic-based, but you're not using one this time. Instead of using just rule-based or using just one single fuzzy or this one or that one, you're now bringing them together. You understand? You're now bringing rule-based. Okay, I'll give an example now. For instance, let's say I'm doing symbolic logic system and I'm doing machine learning. They're all AI-based, but let's say AI using rule-based, now AI using machine learning. And I choose to bring those two together in one work. Do you understand? It will just give you a better representation, a richer value and all that. So this is an example of that. Say, when it is an intelligent system, I'm looking at it from the hybrid point of view. It combines symbolic and sub-symbolic AI, which is symbolic AI, example, rule-based or logic-based. machine learning, example, neural networks, and then data kind of, when neural networks like have more layers, okay? Then when this is just regular data machine learning, where you now just get your data, train your data, and then learn from the data. I gave example of that, like bringing in pictures of leaves in their multitudes. Like if it's a particular disease that I'm trying to work on, I'll now get different versions of it, different leaves with that same disease, post it, and then store it as a database. And then that is my data now. I can now load that data in my machine learning environment. Let's say I'm using Anaconda or I'm using just regular Jupyter Notebook to work on it. So if I load my data, split it into test train, and then be able to maybe 80% of this, 20% of that, using that data, and then be able to train it very well. So when you now want to post anything to it, and if you now post a disease to it, based on information it has, based on the training you've carried out, it can now determine, okay, this man, see this disease, see what it is. Okay. So, but we are now saying, don't do that alone. We are saying, join it with some rule base. Example of rule base. If this leaf is so and so by name, and this disease is, I don't know if you understand. Based on that, okay, it is cassava leaf having this same disease. Then you now combine it with machine learning aspects. That's what I'm saying. Rule based combined with regular machine learning. That gives you a hybrid knowledge-based system. Okay. Now, I hope we are still together. Are we still here?
Yes.
Okay.
Yes, ma'am.
All right. Okay, so symbolic AI, we've looked at the previous one, rule-based versus machine learning. You're also looking at symbolic AI versus machine learning. So here you can have machine learning data, combining it with explainable or adaptive. I will explain the adaptive again. I think I mentioned this earlier. So we can also have combining AI approaches, just purely AI approaches like the knowledge-based plus neural network, case-based reasoning, and EA, which is the evolutionary algorithms, can be rule-based and physiologic. So these are like different possible combinations that you can use. And then for just because you want what, a hybrid system, okay? Applications of hybrid systems can be in medical, financial, or autonomous systems. We already mentioned these cases. You choose an area you want to apply. Somebody already mentioned agriculture. So now that app that you used, I want to see if we can, since you have interest in such area, let's see if we can generate your own app as your project in this course. My dear, if you do that, you can even use it as your final year work, final project that you're able to generate your own. And I think that would be really interesting. Okay. Your AI knowledge-based system that can diagnose this area or that area.
So, sorry, ma, is it for the agriculture?
If you have interest in that area, you can choose to
Sure, I have interest in that area.
So now that you have interest, your PhD projects can be in that area, okay? So, yes, and it can be from a topic, because I don't know how many of you have gotten the project writing book from the department. If you haven't, you better do. It's just 2,500 and it's awesome. So, and what it's emphasizing is that when you're writing your project, let that project be in area that you were taught in class. You can choose knowledge-based systems as an area you want to develop your project in. In that area, we will now guide you in your process, so that as you're writing your project, you will now be able to develop your own inference engine, your own knowledge base, your own user interface. You understand? We don't accept software development But in a case like this now, that user interface will be your software development. We only accept software at PhD level, that's what I mean. We only accept software development when you are using it to buttress a point for PhD or not for undergraduates. Software development, like a software that will do this and that, who PhD work. But if you're using that software to emphasize a PhD work, it is okay. So in this case now, any user interface that you develop in this software, in this case, will be taken as what? Our user interface, right? So it will not be interacting with the inference engine and what? And the knowledge base. I hope it's clear. Okay. So this is about it for introduction. Hopefully my next class will be, I will simply treat two aspects in the remaining classes: inference engine and then knowledge base creation. So let's see, I can just choose a domain. If I like diagnostic, any domain I want, I'll choose, and then I'll use it to create a knowledge base. After that, we'll now choose we'll now develop an inference engine for it. Then a user interface can just be a simple interface, a form that will make you place a request, and then it will forward the request to your inference engine. So let's call it a day. Thank you for being in class today.
Thank you, Mom. Thanks.
Thank you,
Boss,
thank you, Ma.
boss, thank you, Ma. Ma, how do we get the material? At least we need those slides.
I'm posting those to your platform. But people, I see, I'm sorry to say, people that are not in class, I know they give them a material. Though. That's my own. So what I'm going to be creating is a new platform for active. I've done it to cybersecurity people, So I don't, even if you're 100 in the chat group, it's from the class. If I want to give, you send your email after the class. So please send your email as chat now, so that you receive both the video and the PowerPoint slides. So my next class is going to be a practical session. So by God's grace, we'll have that done. Please post your email address.
Thank you, Ma. We will do that. Thank you so much.
You're welcome. I'll
Thank
give you like
very much, Mark.
All right. Please, if there's any question, you can just ask. If not, we'll wait till the next practical class, where you all come with your laptops. Please, this class, if you don't get laptop, go get one. Okay, please, because it has to be a project-based class. You develop your projects. I will assess it. You will defend it, so that if you now choose to work in this area as your final year project, fine and good.
But Ma, are we going to do that practical online? I think giving it to us in class, I think that would be.
No, you know why I prefer classes like this? Because from wherever you are, you can view my system.
Exactly.
If I make it a physical class, I will need generator, I'll need projector, and all that. You understand? Yes. So this one I'm running from my house. I can call somebody, go and put the gem for me, and I'll just prepare myself. So you're directly viewing that. Yeah. So and whatever. Sorry, go ahead.
You can still ask somebody to do soup that you are hungry, because you are doing it from home.
Talk like this. They put bread. They don't mind my children. The wicked. They go put one bread one like that for my food, and they will become here to collect it small, and I cannot talk when I have bread in my mouth. So that's wicked. I can't wait to stop this meeting and fight back before they finish my bread. All right. See you guys next class.
Thank you.